Okay, we're working on chapter 5 exercises, OCaml Programming, correct, efficient, beautiful. We've done a few. We're just going to keep working on it. This chapter was all about modules, so I'm guessing we're going to have some functor examples, exercises coming up here as well. So we'll see what happens with that. Clean up my desk area a little bit here. It's distracting me. Okay, we're good. We're good. Got my lunch plate out of the way. Okay, exercise, date order. Here's a type for dates. Type date equals month end, day end. For example, March 31st would be represented as month equals 3, day equals 31. Our goal in the next few exercises is to implement a map whose keys have type date. Okay, I guess we could play along. We could try this out. I don't have a heck of a lot of experience with maps in OCaml, so I guess we could do that. Let's see how this goes. So we're gonna take this date. Okay, looks good. Obviously, it's possible to represent invalid dates with type date. For example, month equals 6, day equals 50 would be June 50th, which is not a real date. The behavior of your code in the exercises below is unspecified for invalid dates. Okay. To create a map over dates, we need a module that we can pass as input to map.make. That module will need to match the map.ordered type signature. Create such a module. Here is some code to get you started. Okay. So we'll just go ahead and copy this and see what happens. Hey, Prophet, what's up? Hope you're doing well. We are going to try playing with this a little bit. So I think they said it was map.ordered type has just the signature compare. Just TT to end, right? Okay. So basically the idea is we take D1, D2, and let's see, do I want to do a match or do I just want to do if statements? I guess we'll do a match. I think it'll probably end up being nicer. Match D1, D2 with, and now I have to do some record matches. And I probably forgot how to do this, so we'll see what happens. I think I can do something like, is it like this? Month M1, day D1 with month M2, day D2, or is it opposite from that? I can't remember. This pattern matches value of type. It's equals instead. Okay, that's what I always forget. I always forget when to use equals and when to use the other thing. I guess the other thing, is it really only when you're specifying your struct type, or your record type, I should say. Oh god, of course it's semicolon instead of comma. Of course it is. Let me think if that's true. Yeah, I think the only time we actually use colons for records is in this exact point right here, right? Like when we're specifying our record type. And then all the other times we pretty much use equals. I think that's true, or at least that's what I'm going to go off of for now. Right. Yes. Academics. No, it's reasonable. Colons and type signatures equals for values. I get it. Academics would have written Greek alphabet letter. Epsilon? I don't know. Is that epsilon? I didn't take any good higher math courses or anything. Month equals M1, day equals D1, month equals M2, day equals D2. Yeah, okay. So this is fine. So basically what we want to do is say, I mean, we could do it with subtraction since we know these are just ints anyway. Let me just think about it. Let me just think about it for one effing second. Okay. Instead of using a bunch of whens, I guess we could use when. And just say when M1 is greater than M2 and not and. Yeah. Oh yeah, no, this would be gross. I feel like this would end up being gross. I don't know. We'll just go with it for now. So if M1 is greater than M2, then we actually want to return a 1, right? I actually forgot how compare works. I haven't written a comparator for a second. Let me think about it. Usually we would just subtract, right? But would we subtract? I always get the order mixed up. Hey Speen, what's up? Oh, I'm so mad right now. I'm so mad that I get the order mixed up. Okay, I can figure this out though. Don't tell me. I'm just gonna logic it. So if we have ints and we have 432 blah blah blah, right? Oh yeah, I can just use compare. Oh my god. That's reasonable. So I can use compare, but since I have two ints to compare, what is it that I what is it that I actually want to do? So let's think about this. So like int dot compare 3 and 2 is 1. Okay, so it is if D1 is greater than D2, then you do return positive, right? Because usually you would have like AB and A minus B. Okay. Now what's interesting, let's just say we have dates like March, let's say March 3rd and February 14th. No, that's going to be annoying. Oh, I actually think Java's comparators are great. I have never had an issue with Java comparators. It is one of the nicer APIs in the language. And I haven't even used it since Java 8. I don't know if that was there. But I mean, even in Java 8, the comparators were fine. You prefer Haskell's approach though? Yeah, I don't remember how they do it. So the point is what? I guess the point is that if the month is greater, then obviously it's already greater regardless, right? If the month isn't greater, okay, so we could do this. Let's just play around with this logic for a second. When M1 is greater than M2, it's kind of silly, but like we could return 1 here. Okay. Convert to ASCII value and then minus them. I think I'm gonna pass on that. All right, so obviously I don't need the days on that match, but we're just gonna go with it for now. Okay, so here, if M1 is greater than M2, so we know that M1 is not greater than M2. Let's say if M1 is, yeah, okay, so we know that if D1 is greater than D2. Okay, so let's think about this. If the months were equal, then we just compare the dates. Yeah, that's right. Then we return 1. Is there any case that I'm missing? I actually think this is fine. I think this is fine. I mean, technically you return 0 if they're equal. This would be like the lazy case. I guess we could say, I guess we could do the equals case. I guess that's fine. We could say when D1 equals D2 and M1 equals M2, then we return 0. Else we return -1. I think this is actually correct, but we'll find out. Okay, let's just try our compare. Well, I guess it doesn't matter to just put this in our UTOP, in our top level. Okay, we'll just do this. All right, and let's just say date.compare month 3, month equals 3. Unbelievable. Day equals 5 with month equals 2, day equals 25. Sure. We get 1, which is correct. Okay. So this is fine. They just have an ORD type class with a compare method, so you can always just use just tuples if you want lexicographic comparison. Although usually you can just derive ORD and it will do what you want, or use deriving. Oh, right, yeah. Yeah, that's what I'm used to in Rust, which of course took that from Haskell. You just derive ORD or partial ORD, depending on what you need, and you're good to go. Type classes. We like them most of the time. Okay. So that looks fine. Let's make sure that if we switched those, we would still have the same answer. I was doing a vim command to replace that 2 with a 3. Did not work. So we should get a negative here. Why did this just return 1? Oh no, because it doesn't make sense. Oh my god. Okay. I thought I was like short-circuiting this, but I'm not. It's actually just annoying the way I wrote this. Hey Nightshade, what's up? Oh, classic me not thinking through it. This is going really great. I know. Writing a manual comparator. Fuck. I just didn't want to have to write out every case. And then if I am writing out every case, it just feels silly to do it this way instead of just doing like dot access or whatever, you know, like with ifs and stuff. You tried to get Prime to raid me. I appreciate it. It's kind of you. Maybe if I'm doing something more exciting than going through a book, he'd consider it. I don't know. We'll try again when I do Rust data structures. That should be good for Prime. Let's see. Let me just feel this out for a second. Okay. So let's do this. So say we have int.compare 2, 3, get -1, right? And int.compare 25, 5, we get 1, as you would expect. Ooh, I don't completely hate that. Now that I'm thinking through this, I don't hate that at all. OCaml doesn't let me destructure like in a function. Like if I say ddate, I can't do this sort of thing, right? Not what I meant to do. It does. I can do this. Is that how I do it? If I just wanted it to be like that. Let ddate equals day. Okay. ddate month equals 2, day equals 25. Okay, cool. All right, so then we can make this maybe better. I mean, it's going to be a little ugly, but we'll get there. So what if we said month equals M1, day equals D1 here. And then we said month equals M2, day equals D2. That's good to know. For some reason, I always forget that. Okay. And then what we're going to do is match on a tuple with their compares. D1, D2. Okay. We're going to get rid of everything I wrote. Common practice for me. And this is just going to be yeah. We'll get there. It will at least be a little nicer. So if this is 1, then I don't care about what the date is, and I return a 1, right? And if this is 0, that's when I actually care about the date. And so then I guess we should just do our month cases first, and then we'll figure out if there's a nicer way of doing this. Oh, it only guarantees that it's negative or positive. Let's see. Int.compare 5, 1. Yeah, whether or not you're supposed to. It's the way it's implemented right now. Yeah. All right. And then if it's 0, that's when we start caring about our dates. And, you know, again, if we just kind of naive it, because that's what we like here. We like being naive. No, stop this. Okay. Then this would be negative. Every compiler developer's nightmare, I know, right? And then this would be 0. But of course, kind of like to the point that these could be any int. Of course, the pattern match is going to say, no, this actually doesn't work, right? So instead of 0, 0, we're just going to have this be our catch-all. And then that should work. Okay. Nice. Let's try these compares again. Okay. We're feeling a little bit better about that. This is the other way. It should give us a 1. Okay, we're happy about that. And if we say 25 and 3, we should have a -1. And this should be this should be a 0. Okay. So whether or not it's actually compatible with the future changes to standard lib, this does work. Okay, cool. And obviously, if we wanted to make it compatible, it'd be pretty easy. We'd just put variable here instead. We'd bind it to some value. We'd say when x is greater than 0 instead of doing it this way. But that's fine. Now we could make this better. Let's see if we can. We could make this wrong symbol there. Let's make sure that this makes sense. Yeah, because we haven't matched, we're not ignoring the month in any of the other guards above this, so I don't think there'd be any problem here. It's all mutually exclusive, right? And same with this, we could do 0, -1. And thanks to that nice little guard or syntax, our comparator is terser and in some cases easier to read. I don't know. That's subjective, of course. But let's try this one. I didn't actually try this. It does work. And just to be sure, we'll do that guy. Okay, I think we're pretty sure that this works. You bind the positive value to the temp of your CPU. At least the OCaml runtime code documents it as returning -101. Oh, nice. Okay, we're so good then. We're so good. All right, so that's not a bad compare statement without having to do annoying math or something like that. I mean, I don't really know of a way that this would be better. I think doing a compare on the 2 int values and then just matching on all the cases, that's kind of nice. And also, if you wanted to, like, if you switched out the types of these values, then you just change what the compare is coming from, right? And then this code actually should still possibly still work if those compares still only use -1, 1, and 0, but you know, that's okay. This is an exercise. Okay, to create a map, right, so we already did that. So we created our module day. Our compare function looks pretty good. Use the map.make functor with your date module to create a date map module. Okay, so then I think we say module date map equals map.make date. I don't need those. Is that not how you do it? I thought that's how you did it. I already forgot. I just read this, what was that, Monday? And I already forget how it works. You need the parens. Oh, do you have to use parens with functors like this? I kind of remembered seeing it that way. You need parens around module names like that. Oh, interesting. Okay. Wrong place. There we go. All right. Look at that beauty. Functors at work. Okay. So it can't decide what its application syntax should look like, right? We're going to force you to use parens application in the case of functors, but nowhere else. Funny. Drawweed or drawwede or potentially some other pronunciation. Thanks for the follow. I appreciate it. Welcome. Okay, so we created our functor. What are we supposed to do next? Use the map.make functor with your date module to create a date map module, then define a calendar type as follows. The OCaml and JS crossover, no unwanted, inconsistent syntax. Ouch. Pain, Badger, pain. Then define a calendar type as follows. Okay. We'll copy that into our source file and into utop. What? I thought I got rid of the poke.hp alias. Oh, well. Oh, no, poke.hp is string. That's right. Yeah. No, I got rid of it for ints. But poke.hp is still that for strings. Nice. The idea is that calendar maps a date to the name of an event occurring on that date. Sure. Using the functions in the date map module, create a calendar with a few entries in it, such as birthdays or anniversaries. Okay. So we did that, and now we want to create some events, right? So, what is that? Calendar add, except it's a normal function, so I have to do it differently than I was about to do it. Okay. Date map dot. Wait, I got confused. I need to read that again. The idea is that calendar maps a date, yes, to the name of event. Okay, so calendar is, no, I still got confused. String date map dot t. Oh, right. So all this is saying is that the value is going to be strings, right? I just forgot what that literal syntax meant. You know, it's okay. I'm still kind of a noob. All right. So forget all of this. We're going to say that's not how you do it either. I think what we're going to say is we're going to say calendar.add. Maybe? No, that's not how it works either, is it? It's datemap.add and then we give it the calendar. Oh shit, I got confused. Yeah, that's how it works. Okay, so datemap.add. Okay, we're there. And then we give it the date. So let's say month 5, day 12. Oh god, I forgot equals. Month equals 5, day equals 12. Okay. And then of course we have to actually pass the calendar to it. And then we get the calendar back, right? Okay. So the point is, obviously this isn't how this works. We can use a couple things. We can use this syntax, which is probably going to be the easiest to see if this actually works. Datemap.add. Let's do another thing. Month equals 8, day Oh, I forgot the string. I forgot to actually add the string, didn't I? Oh my god. Day equals 2. And then we need the string. B day. Okay. And then this is Asheville. Okay. Now, why do you still hate me? Is it because of... Did I forget how everything in the world works? I don't know. This is not how this works at all. And I'm just like crazy. Do I not know how to use maps at all? I think that's what's going on here. Is that I have no idea how to actually use these. Should we go back to that part? That explanation? I'm guessing it's in functional data structures. Is where we talked about maps. The argument order is key value. But the key is the date, right? And then I'm confused. Yeah, date. Yeah, that's why I thought I did it right. You're too used to string map. Oh no, using the date as a key is super confusing. I mean, I don't think parens are the answer here. I have a hard time believing that that's my problem. Nope. Okay. Tree sitter is also very confused. I know, right? Very confused. Okay. Let's just try a couple things. First of all, I already put calendar in here, right? Let's just do one thing. Let's see what calendar is. Type calendar is just this, right? Map meta be abuse probable. You're missing a let or something that's not a declaration. Oh yeah. You're right. That's the problem. So that would be part of it. But I haven't actually, so I've obviously the type calendar doesn't make any sense. I think this is the part where I'm getting confused is I have my map type specified. But I mean, I think I got confused to how to actually use it. Let's just try maybe calling it. So what happens if I do this? It gives me that. So I got a little confused by the whole type calendar string date map.t. Oh, but that's just okay. Okay, I know what I did wrong. I'm pretty sure. This is where I got confused. Yep. Duh. I was using the calendar type as a value. Okay. I got confused because like basically we gave it this alias, but that wasn't even actually necessary. We could have done this without even specifying this type, and then I wanted to do something with the type. But that didn't actually make a whole lot of sense. And even here, it doesn't necessarily, like, even UTOP isn't like, oh yeah, this is that type, right? It could also be because of my alias. So it would be interesting to see if I say PokeHP instead, if it like just figures it all out. I don't know how much aliases mess with type inference. No, it still doesn't call it a calendar, right? So that didn't matter. But yeah, I was just being dumb. That was the problem, was me being dumb. What's up, Purplish? Okay, so now we have a map of C, right? And we should be able to do things like datemap dot I don't remember how these work actually. Datemap dot mem. So we could do a mem, which is just a mem check. Find. Okay, find key map returns that. Okay, so we could do a datemap dot find. It's really, really annoying to use dates as keys, by the way. Month equals 5, day equals 12, and I think this should return Asheville. How about it? Yeah, exactly, Prophet. I am a little surprised that it doesn't use that. Okay. Anyway, so we got this. Surprisingly, it was a skill issue. We're all very, very surprised by that. Aren't we, class? All right. We'll change it to that so it's a little easier to read for the kids at home. Shook Tiriko Badger. Makes sense. Okay. So we created our map and we added some entries. I didn't even need to read. Okay, I just had to think. How about it? Create a calendar with a few entries in it, such as birthdays or anniversaries. Hey, Juice Box. How's it going? How's it going? I don't know what that accent was. Print calendar, write a function, print calendar to unit that prints each entry in a calendar in a format similar to the inspiring examples in the previous exercise. What? What are you talking about? Inspiring examples in the previous exercise? Yeah, I'm doing pretty good. I literally don't know what they're going on about. Hint, use datemap.iter, which is documented in the map.s signature. Oh, sure. Yeah. So we can just do a show datemap.iter. Date alpha unit. All right. So we can just print that little guy. I guess the thing I'm right. Okay. So then that's funny, Badger. Okay. I think he wants some nice, like pretty print sort of deal. Let's just see what he's on about. I mean, it's good. It's good for me to practice some of this, even though, like, I don't know, maybe all I'm supposed to be doing is a little printf, and that's all that I really need to do anyway. Kind of like I did for fractions. I mean, I didn't do printf. I did toString. Okay. I don't know. I think that's probably what I'm supposed to do. Okay, anyway, let's just start with our function. Let print calendar, which takes a calendar, and yeah, no, it's totally true. I do not disagree with you. It's definitely pretty funny. Datemap.iter print right, I guess let's just do let print e equals print f. So I'm going to put print e here. And I already forgot the type. Right. You actually have to pass the map to it. Okay, that looks good. Now we just have to define our printf. And if I remember right, printf just takes the pattern and then the actual type, right? Okay. So I think all I probably want to do, so this is DE, and I actually forgot. I kind of forgot. I kind of forgot how printf works a little bit. Is it just %s like that? And then maybe some digital percentages like that. And then I can say E and then month, day. If I go back here and fix this to being month, day. Okay. Print F. No. Printy. Printy. Printy C. Oh, I forgot the N. I forgot the N. That might help some things. It's still, is it sprintf instead of printf? Is that my problem? It's printf dot printf. Sprintf is like when you actually want it to return a value, right? Instead of, I always forget. I know C devs think I'm silly, probably. C devs hate me, actually, even though I'm a C dev according to my GitHub statistics. Yep. Printy. All right, so if we say print calendar C, it's pretty bad. It's pretty bad. Let's get a new line, maybe. New line character, anyone? That's nice. That works for me. IKB printf, good. It's funny. Okay. We did it. We printed the calendar. Exercise is 4, write a function is for string car map t to string car map t that given an input map with bindings from k1 to v1, blah, 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 produces an output map with the same keys, but where each key, ki, is now bound to the string ki is for vi. Okay, just give me a second. I'm not going to do this. That just doesn't feel very exciting. What, you want to show the calendar? I didn't say whose birthday that is. Okay. Just pointing that out. You're curious if the week starts with Sunday or Monday? I don't get it, Juice. I don't get it. Oh, you mean like in general, like a generic question? I mean, on calendars, I actually prefer if the week starts on Sunday, even though in my heart it kind of starts on Monday. But it kind of depends, because for the last 5 years I've actually worked on Sundays, which sounds cursed, except just hear me out for a second. I don't work on Thursdays. I know it sounds weird, but I switch Thursday and Sunday. I like it better most of the time. Oh, when you get to next, yeah, when you say next Sunday, do you mean 1 day or 8 days? If you're on Saturday, that does get confusing, because most likely you mean in 8 days, but I would never say that. Now, if it's Monday and I say, let's do it next Sunday, I probably mean in 6 days. So I think the real takeaway, Juice, is don't be fucking confusing in your language, right? Oh yeah, for sure. That's actually where it started. It's crazy. I actually love having a weekday off. Everybody's at work, things aren't busy. I mean, my daughter is older now. She doesn't do as many things with me anymore, but we can go out and do things while everybody else is at work, or school or whatever. It's great. Standard library set module is quite similar to the map module. Use it to create a module that separates sets of case insensitive strings. Strings that differ only in their case should be considered equal by the set. For example, the sets gur, arg, and arg gur should be considered the same, and adding gur to either set should not change the set. Okay, I guess we could do this because I haven't really played with sets in OCaml very much. So there's a set make that takes an ordered type. Okay. So I guess the point of it taking an ordered type is that actually how they determine equality. So I guess I want like case insensitive like this module ci stir equals struct type t equals string, let compare s1 s2 equals match s1 s2, but I probably don't want matches. I actually want to do, well, I do want to match. Do I want to match? Hold on a second. Ooh, that's even better. I can just return string.compare and then just lowercase both of them. Do we have string.lowercase or something like that? lowercase ASCII. We'll go with it. Let compare s1 s2 equals string.compare. And let me just make sure that actually just returns. Yeah, this should be fine. So why do you still hate me? Oh, I have to do an end. That might help. Is that all I needed? Oh no, what did I do? Uh-oh. Emacs froze. Emacs? I'm sorry. I didn't mean it. See you, Badger. Hope your stand-up is wonderful. What? What was that weird freeze, Mac OS? That's not even Emacs's fault. That's Mac OS's fault. All right. I think this works. CI stir compare gar 0. Boom. I know programming, kind of, for the most part. I've only been doing it for a long time. Okay, now we want to do what now? Use it to create a module that represents sets of a case-insensitive strings. Okay, so then we would say module CI set. Gonna go lie to your Scrum Lord about how I worked instead of apply to jobs today. Nice. I didn't even see that. That's hilarious. Map. Nope. Set dot make CI stir. All right. Looks good. And then CI set dot empty. Let's do a let s equals CI set dot empty. Oh God. CI set dot add gur CI set dot add gur. Good enough. Okay, let's do like an of list or to list thing maybe. CI set dot to list as, so then we'll just print it out. Nice. No, I hate cool stuff, Prophet. Yeah, what do you got? What do you got, Prophet? Show me something cool. All right. Yay, we did a set with a custom comparator. Pretty cool though. I mean, TBH, right? It's pretty freaking cool. Write a module type toString that specifies a signature with an abstract type T and a function toString T toString. Oh no. Now we're really going to get into stuff that I don't remember. I can't remember who said it right. I guess it was Purplish probably last time. That was like, yeah, you think you know this until you actually go and try to do it. And it's kind of true. Okay. What do we got? Loc by overlap. We got a type T. We've got to compare. Reading is different from writing. Okay. Prophet's going to tell us what this does. Polaris, by the way. The language that is going to take over all other languages. This uses a compare method that compares source locations in the same file, okay, in a way where anything that is contained in one is considered equal. Let's see. Compare a method that compares source locations in the same file in a way where anything that is contained in one is considered equal. So long as nothing overlaps, you can just look up the cursor location and find the value associated with the range that it's contained in. Source location. Oh, okay, got it. Okay. In a way where anything, so like you're in a file, because this is in your LSP, right? So you're in a file and contained, right? Okay. So like you have a range, right? Like say you have a structure, right? That's like some syntax that's like column 1 or whatever, line 1, column 5 to column 10, and you're at column 6. And so if it's contained in column 6, then it's considered equal. Yeah. Or, whatever. Since you're at column 6, it's contained within 5 to 10, then it's considered equal. Oh, yeah, that's very cool. Very cool. Neat. Yeah, thanks for sharing. That's fun. Okay. What was the next exercise that I was not excited to do because I don't remember how to do it, even though it's easy? Write a module type toStrings that specifies a signature with an abstract type T and a function toString tString. Sure. So I can write a module toString equals struct. I have type T that's well, type T is abstract, right? Oh, it's just a module type. I don't actually have to write the struct. So, okay, let's see if I actually remember how to do this. Can I just do module toString equals sig, and then I still say type T, and then I say val toString. I forget how to do the things right now. Val toString is it has type of, like the way that we do it everywhere else. T to string. And then end, maybe? No. Expecting module expression. All right, let's just look real quick. I forget how the syntax works because I haven't done it enough. Oh, module type. That was the thing that I should have figured out. So when you're defining a module type, you write module type. And when you're defining a module struct, you just write module, right? It's the definition versus the type. Okay. Right. I believe this is correct, even though, I mean, it's just going to print out exactly what it is, but I think that's correct. Okay. So I forgot the one thing about the module type, the type keyword after module. Okay, write a functor print that takes as input a module named m of type toString. The module returned by your functor should have exactly one value in it, print, which is a function that takes a value of type m.t and prints a string representation of that value. Right. So then this should be, I think I can just use module if I remember right. Module print takes m, which is toString, and returns struct, which is just print let print print equals m.toString end. Believe that would work. m.t toString. Yes. Okay. That looks good. Let's just put all of this in utop to make sure that my LSP is not lying to me. Yay, we wrote a functor. Okay. Create a module named printInt that is the result of applying the functor print to a new module int. You'll need to write int yourself. The type int.t should be int. Hint, do not seal int. Okay, hold on. I am not going to call it int. I'm going to call it myInt because I really don't want to shadow the other, like the standard lib module. Module myInt equals struct type t val to string t to wait no that's not right. Let me read it one more time. To int. Okay, hold on. All we have to do is right. It's like this. It's like the CI stir, right? No, hold on a second. Oh, right, because we haven't actually applied this yet. We haven't applied this yet. So type t equals int. You can also do anonymous modules, by the way. Right. Yes. Yeah, he went over that, and I still am not used to it enough. Module myInt equals struct type t equals int val to string, not val to string. Let to string equals int dot to string t. Oh yeah, I don't even need to do that. I just need to do this. It doesn't like that. Okay. Why doesn't it like this? Is it just because I didn't have the end? It's just because I didn't have the end. Okay. One second. I think this is right? I think that's fine. And then we just use printInt, right? And then we can say module printInt equals print myInt. Okay. And then if I say printInt dot print how does this work again? It just takes an int, right? Okay. Just making sure. Oh, sometimes. All right, so I can literally just do this, and it's this. Okay. An interesting exercise that's not hard, even though I'm slow. Okay, I was kind of it. Use it to print the value of an integer. Sure. I mean, I guess this is fine just to get like little examples going. I mean, at least these are 2 stars. That's aptly rated, I guess, for difficulty. Create a module named printString that is a result of applying the functor print to a new module myString. You will need to write myString yourself. Hint, do not seal myString. Experiment with printString in UTOP. Okay, I don't care about this because I know where he's going. I don't think we need to do that. Yes, we know we can reuse a functor. Explain in your own words how print has achieved code reuse, albeit a very small amount. No. Print string reuse revisited. The print string module you created above supports just one operation print. It would be great to have a module that supports all the string module functions in addition to that print operation, and it would be super great to derive such a module without having to copy any code. Define a module string with print. It should have all the values of the built-in string module. It should also have the print operation, which should be derived from the print functor rather than being copied code. Right, so we're just going to do includes. We'll do this one just to make sure that we know what we're doing, but we'll just do it with printint so that I don't have to write something that I don't feel like writing. So module print string equals struct. And we're going to, that's not what I meant. I already forgot what they called this. String with print. Okay, we'll just call it int with print. And then we're just going to include print int. And we're going to include int. Yes. We'll see how this works. Hey Des, what's up? Okay, so int with print now has all this stuff. It is kind of interesting. Let's see. Show print and okay, I guess that makes sense. Because that's not actually returned, the type T. Interesting. I guess I was wondering, like, what happens if you include 2 modules that have the same thing defined? Oh yeah, he talked about this, didn't he? It just gets it is order of declaration. So even though my int2 string and int2 string are identical, technically if I do this, my toString comes from my int instead of the stdlib int module. Okay, right. I remember that now. toString. Oh yeah, that's interesting. Another kind of like hint, not that this is like completely reliable, but like this toString method or function, whatever, on this module is at the very end, since it's kind of like being added at the end from my int. And I bet print's at the top. I wouldn't be surprised. Yep, print is at the top. Yeah, it's at least a nice visual reminder of the fact that it goes from top to bottom. Okay. That looks pretty good. Implementation without interface. Create a file named date.ml. In it, put the following code. Does a backend developer have to know HTML, CSS? It depends on the job. I would say, like, if you're a junior, like if this is your first dev job, I kind of doubt that people would expect it. But It's not like it's hard to know just basics. I mean, I think when people say, "Do you know HTML and CSS?" as a backend developer, I think it really means if you looked at this web page with this simple CSS, do you have like a basic idea of how this works? And could you make small edits to it if you needed to? I think that's a fair characterization of it. Of course, I started full stack. So, I mean, I probably don't have like the best perspective on how much you should know because I used to know a lot of it. But I mean, I've had to write. It's kind of like as a backend developer, it's not uncommon for you to be like, get a task maybe to write an internal tool, right? So like we have a whole service called internal tools at my current company, and we write server rendered HTML templates using some CSS framework. I don't remember which one it is that just makes things really easy. I didn't have to choose that. And I know how to work with it. It's like if you know how that works, yeah, that's a good example, Purplish. If you can put like a basic web front end on your tool, that's great. It doesn't have to look perfect. It doesn't have to be pretty. It just needs to be functional, you know? I think I knew I needed to become a backend developer instead of full stack when I built an interface at my last company on my last job. My first job, which was my last job. How does that work? Anyway, this is my second job. Okay. Yeah. No, if you do not need to know Flexbox as a backend developer, I would be really surprised if somebody expected you to know that. No. Like as a backend developer, it's like I can write you a table. You know, I put this in a div and I use this little copy and paste CSS framework. I hope you're happy. But oh yeah, what I was saying is that at my job where I was full stack, I wrote an interface. Like I did a UI for users technically. Um, and the feedback I received was it looks like an engineer wrote this. And I thought about that. It stuck with me for a while because it was like, yeah, I should not be building UIs because I literally couldn't care less. Like the aesthetic appeal of an interface. Like as long as it's functional, I'm pretty happy with it. But yeah, pretty funny. It's a good question. You're confused about how there are technologies. I mean, oh, I was about to make a joke because I knew it was a typo, Does, but yeah. Dang it, you corrected yourself too quick. Uh, okay. There's a lot of technologies. I think you just have to look at, like, again, this is what I'd say for anybody, whether they want to get into front end or back end or full stack, whatever. Look at the job, look at the JDs, right? Look at the job descriptions for the jobs you want. What are they asking for? What are they requiring? And if you can check 70% of those boxes, you're probably doing okay. You know, eventually you should be able to check 100% and get into the nice to haves and all of that stuff too. But especially if it's your first job, it's like, oh, you're checking 75% of those boxes that they're asking for in the, like, even in the required category, in my opinion, depending on the JD. Like some of them are so long, you know, like that's what I would base what technologies actually matter is job descriptions. Don't base it on Twitter. Don't base it on what people are doing in Twitch. Honestly, it's just like, if your goal is to get a job, figure out what you need to do to get a job, not to be cool on the internet. Let's see. We did that one. DateML. Create a file named dateml, and it put the following code. Also create a Dune file, load the library into UTOP, and UTOP open date, create a date, access its date, and convert it to a string. I've already done that plenty of times. I'm not going to bother doing it right now. And then MLI files, put in the following code, then redo the same work as before in UTOP. Yep. Done that a lot too. Not going to bother with that. Implementation with abstracted interface. After doing the previous two exercises, edit date MLI and change the first declaration in it to the following. The type date is now abstract. Again, redo the same work in UTOP. Some of the responses will change. Yeah. Explain in your own words those changes. The date is abstract. Yep, that's the changes. Okay. Printer for date. Add a declaration to date MLI and add a definition of format to dateml. Hint, use format.fprintf and date.toString. Now recompile load utop, and after loading date.cmo, install the printer by issuing the directive install printer date.format. Okay, so again, like this is really cool. I love the install printer stuff, but I'm not going to bother doing this because I don't care that much about that. That's not why I'm here. Refactor Aerith. Download this file, algebra.ml. It contains 2 signatures and 4 structures. Okay, this might be fun. There's a lot of words, though. It's a lot of words. Let's see if we actually want to do this. What's distortion 2? I don't even know what that is, man. I'm not cool like you guys. Oh. I mean, I'm speed running the game of OCaml right now. I didn't mean to copy it. I should have just moved it. But that's fine. That's fine. Algebra. Okay, let's look at this little file here. That's what multi-twitch is for, man. Watch us both at the same time. Ring is a signature that describes the algebraic structure called a ring, which is an abstraction of the addition and multiplication operations. Field is a signature that describes the algebraic structure called a field, which is like a ring but also has an abstraction of the division operation. Int ring and float ring are structures that implement rings in terms of int and float. Yeah, that's so me, whimsically. I'm just breaking records all the freaking time because of my speed. Int ring and float ring are structures that implement rings in terms of int and float, and field and float field are structures that implement fields in terms of int and float. Yes. Int rational and float rational are structures that implement fields in terms of ratios, aka fractions, that is pairs of ints and pairs of float. I love the note. Math nerds, try not to worry so much. Oh yeah, that makes sense whimsically. Refactor the code to improve the amount of code reuse it exhibits. To do that, use include functors and introduce additional structures and signatures as needed. There isn't necessarily a right answer here, but here's some advice. Okay, I don't need the advice. The types of all modules should remain unchanged. You can also see those types by running OCaml c-i algebra.ml. Okay. So let's start with this OCaml C, which I might not actually. Let's hope I do. Huh. Now to TIL. Yeah, I don't need the advice. Classic. OCaml C-I. Never knew. So that's even faster than using utop. If you wrote an ML file and you wanted to get a quick MLI, you could just run this and then, you know, put it into an MLI file. That's cool. I guess we'll just do that. It's not like exactly perfect, right? But it's good enough. We'll just call this algebra.mli, and then we'll run a diff on it when we're done. This sounds kind of fun to me right now for some reason. So let's just see what we can do. So we have a ring and a field. Ring has addition, subtraction. Actually has addition, unary, negative. Multiplication. Addition, negative, multiplication, slash. Okay. Int ring is ring. Okay. Equals struct type t equals n. Let 0 equals 0. Yeah, something like that. You know I'm bad at math stuff, like academic math terms and stuff. Entering int 0, 1 plus neg prod to string of end and field float ring float field int rational acti pH water. If you mean the particular brand, no. If you mean, am I drinking something that's called alkaline water and electrolytes, then yes. Afraid so. I just like the way it tastes. It just tastes better. Tastes better than normal water. Than most bottled water I can get. And there's no way that I'm going to drink sink water in the US. It's just not going to happen. Too many irresponsible city water systems to drink sink water in the US. It's for crazy people. Yeah. Who knows? It's like a sixth of the screen too. It's really funny. Okay. Float rational field type T. Okay, so then this is another definition. All right. So obviously there's a lot of things we could do. Implement quaternions, bitmap. You know, I don't know what that means. I think one of the easiest things we can do to like make this code better is delete all the new lines. Because why do we have so many effing new lines? You know? So that's already going to make this code much easier to read. Your wife's picky about water like me. Yeah. Yeah, my partner's also super picky about water. Probably pickier than I am. Let's see. I guess we can try a little %s / n. Can I do the whole like dollar? No, is it caret to say that it's beginning's the first thing on the line? And then let's just do this. Okay, there we go. That saved me a good amount of work. I mean, that's so much easier for me to read, honestly. I hate so many new lines like that. Oh, right. I could have done /n / -n. Yeah, that's a good point. Okay. Did we get them all? No. Still not. Okay. We did it, guys. We didn't change the signatures and we made the code much better in half the lines of code. Perfect. I think that was his point. I'm pretty sure that was his point. What's up, Nunez? Okay. What I can't remember is if I can do an include in type signatures. Blessed up kid. Meta is a small indie company. You know, I had the name Meta before they did, so I'm pretty mad. Include for module types works. Cool, thanks. So I don't know what I'd actually want to call it. I mean, maybe I just want to call it ring. Maybe instead of doing anything special here, I could actually just do something like this. Let's call it field prime. Equals sig include ring val division t and okay. And I just want to see if that has the exact type as the above. Yeah, except for order, everything else is the same, so this should be fine. You could do semi-ring field, yeah. I think I'm gonna start with that. I forgot to hit the D, so that didn't do anything. Okay. So that's a little bit nicer. I mean, it's like we could do like include, obviously here we could do the same thing where we say include entering yeah, we were doing some functors earlier. And then something like this. Int rent. Close. Not quite, but close. And now it does not have the type field because I deleted the type field. Okay, yeah. I don't need this anymore. That was on me. Okay, why do you not like me? That's rude. Super rude for you to not like me. Values do not match. Val int is not included. TTT. Oh, it's because I probably... Do I have to have my own here? No, it still doesn't like me. Okay, what did I do wrong? Oh, I bet it's actually that my type T needs to come after. It could be even that. It's not order. Because you aren't using include in field. Oh, because I didn't include. Wait. Hold on. Ring T is different from T field T. Yeah, no, I am. Okay. Let's just OCaml see this and see what happens. Without the I. Well, maybe the I still gives me the same error, right? Okay. Values do not match. Val0 int ring.t is not included in val0t. The type int ring.t is not compatible with the type t equals int. File algebra line 3 expected declaration actual declaration. Okay. I don't see where you get the whole line 3 from. I guess it's this, the 0. Val0t. Maybe this won't work this way. Like I want it to, but maybe it won't. Maybe ring and field should be functors. Would that save anything for me? Would that change anything? I really thought this is just going to be pretty obvious. But it wasn't. So this doesn't change. I mean, let's see what the error is here. It just changes this, which makes a little bit more sense to me because it's at least actually talking about what I'm looking at. According to docs, what I'm doing should work, right? Yeah. So field includes ring. Int ring is a ring. I include int ring. I mean, I should get an error here if there was a problem. Like, let's put some of this in UTOP and see where it says we're wrong. Okay, that looks fine. Not what I meant to do. This is also fine. So module type field T. Okay, exactly what I expected. They explain why it doesn't work here. I literally just read that Monday, but I'm sure I forgot. I guess it's because, I mean, my assumption is that while this works for a signature, it doesn't work here because by including int ring, I still can't just like define a new thing on int ring.t. And I'm guessing that's the problem. So I think the problem is there, right? Okay, so this is fine. But then when we get to this, it is not. So then the only thing I could imagine doing is, of course, one of the problems is that the type T is actually abstract here. Because we've already made this T abstract. Oh, I bet that's the problem, is actually the abstract types. So let's change this. to, we're going to call this int ring prime. Now this is already breaking his rule of not changing the types of the program, but I'm thinking he just meant don't change the signatures of the resulting modules. Module int ring has type ring equals int ring prime. I think that's the right syntax. It seemed to be fine with that. What do you use, Scott? It's all good. NeoVim? Yeah. I use Emacs mostly because of Lisp, to be honest. Not that you can't write Lisp in NeoVim, but when I started working with Clojure a little over 5 years ago, that's when I started using Emacs. So the Lisp support in Emacs is very strong. And yeah. I use evil mode. So that's kind of interesting. It just says int ring ring there. I wonder what OCaml I says about it. Okay, so I was right that it was the abstract type thing, because now I don't have any more errors there. Oh yeah, I forgot. I'm just in my freaking terminal already. Let's see what they call int ring. Oh, well, it does change the signature, but I don't know if I care that much right now. I like it because I can do quite a bit with it. I use org mode to track my work time and take notes in addition to coding. Yeah, org mode's probably one of the biggest draws to Emacs that I've never used, but I know it's awesome. Yeah, Eva mode's very well done. And yeah, the Lisp support, really easy language support. I've gotten really used to, and this is probably one of the things that sounds hard to me about NeoVim, even though it probably shouldn't, and in reality it probably doesn't matter that much, but being able to have a single window that I just switch between all of my buffers, even from other projects, it just works well for me. And I think part of that is like working in a mono repo and Clojure. Without that would be really annoying. But I don't know. I'm sure people do it and are happy. Whoops. And then we just use projectile to actually deal with when you want to just run something on a specific project. But I do plan on using NeoVim some. I just haven't got around to writing a config for it. So I don't really care about his whole like don't change the signatures. Because at the end of the day, like int ring ring is still the same signature that it had before, that int ring had before. So I'm not going to follow that advice for the exercise. We're just going to keep going and see what else we can do. Okay, so obviously we can do the same thing, but that means, again, we have to do our same trick here. We're going to call this float ring prime so that we don't have an abstract type. And then we're just going to do float ring. Ring equals float ring prime. Okay. And then I can't see what's happening. Include float ring prime. Okay. That looks good. And then finally we have int rational, which is a field, and float rational, which is a field. Let's think about this. Hey, Zen. Yeah. Good joke. Classic Emacs joke. I use that one on some people when they're like, why not use this editor? And I'd be like, I don't think I could replace my OS with Helix. How would that work? NeoVim couldn't be my OS. That doesn't make any sense. What are you talking about? All right. Int star int. Okay, we got some tuples, blah, blah, blah. I'm not seeing a whole lot here. I mean, obviously, I don't know. Like, I'm sure there are some more things that I could do. I'm just... I mean, obviously, these are kind of silly. Some of the plugins are crazy. Yeah, you're right. Just watch Dylan's stream, right? You'll see some wild NeoVim stuff. You have org mode on NeoVim? Interesting. I mean, honestly, if I was just writing this code and this is what I ended up with, I would probably not do anything different because I think there's not a whole lot of duplication here. There's you know, it's fine, honestly. I mean, I guess what the int ring 01, no, that's not any different, right? Because it's just rationals, you know. Yeah. Okay. I don't see a whole lot that I would change, honestly. Let's read his notes now and see if I change my mind. I'm pretty happy with where that ended up. Hey, learner, what's up? Thanks for the follow. No name should be directly declared in more than one signature. For example, plus should not... Yeah. I mean, I get that. Oh, no, I'm already doing that anyway. Because I only have 2 sigs, ring and field. So actually I did that. Okay, you need only 3 direct definitions of the algebraic operations in numbers. Once for int, once for float, and once for ratios. Okay, so he's just saying use include. Okay. So use include in your signatures, use include in your structs. Yeah. The rational structures can both be produced by a single functor that is applied once to int field and once to float field. Okay, this might be fun. The rational structures can both be produced by a single functor that is applied once to int field and once to float field. Okay. So with int field and float field, I mean, I wouldn't do this in real life, but we could do it just for the exercise, I guess. Hey, cool. Awesome, learner. Yeah, OCaml's been a lot of fun. I've done a fair amount of OCaml, but I wanted to do something kind of harder and realized that I don't have really good foundations down yet. And so I thought, why not just like read this book on stream and work through exercises, all that sort of stuff. I think I might already. I don't know when I'm going to finish though, because I might be done after 5. Like a lot of this stuff is fine, but it's not all that relevant for me. I already know how to use refs. I don't care that much about mutability. I mostly want to use the immutable stuff. We might look through this at some point, but I think for now I might just leave it as chapter 5. Kind of like you're doing with Rust without the streaming part. That's cool. Are you going through the book, Scott? Or are you going through another resource? Reading the book? Yeah. The book's great. Yeah, for sure. Yeah, CS3110. This is obviously just where I happen to be right now, but you can read the whole thing online. You can get a PDF version if you want to put it on a reader or something. Finally making some sense. Yeah. The book's really well done, I think. I didn't read it front to back at the beginning, but I think I've managed to basically read the whole thing at this point. You know. Let me think. Yeah, I did finish it. That's right. I forgot. I've read actually every I've read all of the official Rust books that are out there. The only one I didn't finish is the Rust reference, which is literally just mostly written for people who are working on the compiler, but it's still interesting. Module. Oh yeah. So basically there would be like a functor, a rational functor, right? And so we would define a module rational that takes, let me think. Right, that takes a field, right? So this takes a field. And then it returns a struct where and it's also going to return a field. Okay. So technically this returns a field as well. Now I might have to change field. Let's see what field looks like again. Right, fields abstract. Let me just think about this. Is this going to work the way that I think it does? Yeah, this should work fine. So we're still going to say, oh, no, it won't work. The reason this wouldn't work is because of that being abstract. I don't think I can do that. Can I? Can I say type t equals f.t star f.t if f is abstract? I wonder if I can. Is this valid? Oh, okay, right. It's because I'm doing this. It is valid. Oh, so you can do that even with an abstract type. Interesting. That's surprising to me for some reason. I don't know if it should be, but it is. Yeah, actually, Actually, let's keep that deleted until we finish writing all of this. Let 0 equals f dot 0, not capitalized, f dot 0, f dot 1. Let 1 equals f dot 1, f dot 1. Let plus equals let me think about this. Yeah. A comma B, C comma D equals wonder if that will that just work now? Let star. Let me just think about this. Right, it's not an operator. Or is it? Can I do it that way? Let me think. So if I have, all right, but it is abstract. Okay. Well, I mean, I know. Okay, we'll just keep writing the code and try not to think so effing hard about it. We'll just try this. A star D plus. Technically, this would be F plus. I don't think this is going to work this way. And because it's not going to be able to figure out all of this. So I think I have to use these probably as regular functions. So we'd probably have to say f dot plus, but I don't even know if this is valid syntax in OCaml. We're just making shit up at this point. F dot star. Now this is looking like Lisp. That's what's happening right now. Which, I mean, I don't hate. I'm not having a hard time with that at all. Okay, so obviously that didn't work. I don't know if I can do like this. Is this valid syntax? I don't think so. Okay, let's just try putting this up here. And let's make this simple, even though it's incorrect. And just say f dot plus AB, just to see what happens. Okay, just to figure out where the syntax is wrong. Also doesn't work. Now I imagine I can do something like plus here, but of course it's not like that's actually going to work. Yeah, expression was expected of type A star B. Oh wait, why did I put a weird equals over here? Oh my god, I just have a dumb equals. Oh my gosh. Hey, Lewis. I don't know. I know who you are, but I actually don't know how you pronounce your first name. So sorry if you do not pronounce it as Lewis. Hey, Chris, how's it going? CM, Lewis, welcome. Thanks so much for the raid. Super appreciate it. If you don't know who Lewis is, he is the creator of Gleamling. And very cool to see him streaming, and I super appreciate the raid. It's really nice of you. Let's see if I actually spelled your username correctly. I think I did. And how about that? I actually had not followed you yet. That's funny. But like the French way, so it's Louis. Thank you. I'm glad you like the fireplace. Yeah, so I'm meta. Okay, cool. Louis, I can do that. What's up, Dylan? And roasted. Meta you. I do a bunch of different things. I do Rust. Yeah, we haven't done the kiddie pool yet. We're thinking about doing a kiddie pool in summer, which, in case you aren't familiar with American English, all that means is a small pool. It's not anything weird. But yeah, I do quite a bit of things on stream. I do Rust, I do Nix, and I do OCaml. That's mostly what we do these days. I've done quite a bit over the last 6 months when I started streaming. Eligible for hot tub streams. Yeah. We are going to put like pool stream hashtag on there and just have like, yeah, just have like a pool on the background. And it's just literally just like a video. If I can find it, a video of just like a pool in the background, just like a kiddie pool though, like the blow up inflatable pools. I think it would be excellent. It'd be a great meme. Yeah, so I did a tour of languages that some of you guys might be interested in. Gleam is cool. I've been watching Dylan have fun with it. Come on, Nightbot. Nightbot, are you sleeping? Is Nightbot sleeping? What's going on? Nightbot? Why are you sleeping on me? Oh, there it is. So yeah, last year, November time, we went through 12 different languages, which was a lot of fun. These were all languages I hadn't used before, except for Haskell. I used Haskell about 5 years ago. For my day job, I actually write Clojure, which is a Lisp on the GVM. Did I say GVM? Did I really just say GVM right now? Nice. Okay. I don't know what I said. Yeah, which is a Lisp on the JVM. And I've been doing that for about 5 years, kind of nerdy functional programming stuff. But this was a lot of fun. I really did say GVM. That's awesome. I love that for me. And all the VODs for that and stuff like that are on YouTube if you're interested in that. I also did a bunch of Rust DSA stuff, which was a lot of fun. And that is also on YouTube, which you can find via that link. But if you want a direct link there, and that's mostly here. We did these. We're gonna get back to it. Actually, we're gonna re-implement it now that I know Rust a little bit better than I used to. And this is kind of my way to learn Rust. But we did a bunch of fun data structures in Rust that people felt like were really hard, and they really weren't. I mean, some of them were, but it wasn't as bad as you think they would be. But yeah, as a junior engineer, frequently changing tech stacks at work feels overwhelming sometimes. Yeah, no, that's fair. You're just trying to get a handle on everything, right? So I imagine you guys were working on Gleam. Louis, if you're still there, I hope your stream went well. Let me know how it went if you're still around, and or the people that came along. Yeah, cool. What were you guys working on? Yeah, it's totally true, Griff. I mean, that is one of the things, like when you learn a bunch of languages, you just start to you stop thinking about all the differences as much. Template for Gleam backend apps. Sweet. Very cool. Yeah, I'm super excited about Gleam. I haven't taken the dive yet to try it out, but I'm a big fan of the Beam. I wish that it would have made sense. This is for any of you functional programming nerds. This is kind of the mind fuck, if you will, of my current job, where I've been 5 years. Great company. Going to be moving on this year at some point, but we're in the telephony space, VoIP space, and we use Clojure, which is great. But like, why are we not using Elixir? or something on the beam. Like if we're using a dynamic functional programming language, who would choose Clojure on the JVM versus the beam when you're dealing with telephony? That is a very interesting choice from my perspective, but that's okay. I still like Clojure, and it's a lot better than most. Yeah. JVM famously known for its infinite scalability. Yes, exactly. Really, really good at not yeah. So Elixir, for those that don't know, for those that aren't complete functional programming nerds at this point, Elixir is a fairly newish language. I guess it's about 10 years or so now that runs on the beam. Gleam is an even newer language than that runs on the beam, but has types. Yay, types. And that's all from the beam, also called Erlang VM. And that is runs a hell of a lot of telephony in the world, especially Europe. Erlang was developed at Ericsson, if you're familiar with that, the name of that company, and that's where the name came from. And yeah, so that's just a quick little context to my wondering, why are we on the JVM in telephony? Yeah, I mean, I think JVM is super powerful for certain things. It has actually been before I had this job, I was working doing full stack JavaScript, TypeScript, and Java. And so I've been on the JVM basically for the last 10 years. So I'm definitely ready for something new. Is it true that Beam invented K8s years before K8s? I mean, it invented basically, how old is Erlang now? It's probably 30-ish years old. How old is Erlang? Yeah, 80s. That's what I figured. About as old as I am. Like the concurrency model in Erlang and the ideas that they developed in Erlang were like super far ahead of their times, and basically the rest of the industry is just now, like just in like maybe the last, what would you say, maybe 5 to 10 years, actually saying, you know what, yeah, these ideas are actually really good, let's try some of this. And meanwhile, Erlang's just been doing it for 38 years. No, Nightshade, sorry to Google Erlang and get you all excited and then close it out, but yeah. Anyway, appreciate the raid. If you're into functional programming and just other kind of nerdy things, then send me a follow. I'm around. I typically stream 3 to 4 days a week. Typically do a mix of the Nix, OCaml, and Rust, like I talked about. And yeah, Gleam works on the Erlang VM. Now, I would assume I assume that Erlang's not actually the compile target of Gleam, but somebody could correct me if I'm wrong, and it actually goes to what I imagine is like bytecode, similar to bytecode. Gleam-a-lang. What does Gleam actually compile to? Yeah, the Beam is running bytecode. They all compile to that. Yeah. Okay. Thanks. Yeah, same thing Elixir compiles to, right? Yeah. Yeah, Earl source or JS source, right? I mean, I knew you could do JS as well. So yeah, Gleam's a very cool project. I'm very interested to see what they're able to do that other people haven't been able to. I'm a big fan of strong types and good type systems. And the fact that Gleam is implemented in Rust also I think bodes well for the type of engineering that goes behind it. So very excited about that project. Okay, so let's see if this was actually my main issue the whole time or if it was something else. Actually, let's do it this way. Let's see, Y4. Let's see what the OCaml syntax that I'm just not grasping as here. Like, how do I use this? Does anyone who knows OCaml here? So basically I created a functor that takes a field, right? And field has these sorts of operators on it. And I want to use those operators, but I've tried it a few different ways. I've tried it as like an infix. Oh, wait, no, I tried it as an infix, but then I remember now. Okay, I think this might have been my problem. I don't know if this is how we would do it, but let's just try this. Not what I meant to do. Okay. Was this my problem the whole time? No, that still doesn't work, does it? Unbound value dot star. Okay, so Gleam doesn't compile to Beam bytecode. It compiles to actual regular Erlang. Okay, you could take the Gleam compiled to Erlang and read it like a regular Erlang program. Okay, that's very cool. Very cool. Thanks for answering that. Okay, what am I completely missing here? Let's take an example like this float ring. Let's take float ring as an example and play with it in UTOP. Oh, you're referring to Gleam and Erlang. That's funny. Yeah, don't talk about Elixir because then Ryan will just randomly show up. Let's see. Let's try float ring prime. Did I actually put float ring in here? No, but I did put int ring. Int ring is fine. Let's try int ring prime plus. Let's do a show on that. Syntax error. What if we put it like this? Okay, then we have this. Okay. Now, if I say int ring prime plus like this, 1, 2, I get 3. And but I can't use it as an infix operator. Is that right? Yeah. Okay. Can I put it like this and use it as an infix operator? No. So I can only use it as a normal function at the beginning, unless I'm just missing a syntax. Yeah. Okay. Oh yeah, that's true. Okay, I figured it out. We're good. So basically, this is going to look ugly as hell, and there's probably a nicer way to do it, but I don't know what it is because I'm a noob. But we're going to delete that, and we're going to change this to have parens all the way down. It's going to look a lot like Lisp, and we're going to love it because we love Lisp here. And there was definitely a nicer way to do that, but that's my correct way of doing it. Okay, at least it compiles. Yeah, the gist is you have to ship the beam with the exe, yeah. Yeah, I was wondering if there was something like that available. That's cool. Okay, so that's ugly as sin. Ugly as sin. Let's do our unary, which will be less ugly, just because it is. And that's AB equals F dot negative A comma B. Okay. And then our divide is going to take A, B, C, D. And divide is going to be F dot star AD F dot star BC and multiply is just going to multiply A and C and B and D. Very good, very good. To string AB equals. So here this is like the one place where we currently don't have like technically we have string event and string of float. I'm trying to think of a nice way to abstract that. I don't actually know. I mean, maybe those are the things that we just keep outside of the rational. Functor. No, there's got to be a way that we can do this nicely. So this takes a field. It returns all of that. But in order for this to be a field, it's 1 a.m. All right, learner. Have a good night, dude. Yeah, see, you're really decent. I appreciate you hanging out. And I missed some follows. Yeah, thanks. Really decent. And new Emacs coin. Let's go. For the follow. I appreciate it. So what are we doing? What am I trying again in OCaml? I'm trying to actually figure out how I want to abstract the string of int and string of float, because technically those are outside of these. So, float dot no. Is it in string? No. Because we don't have a toString in. Oh my God, I'm silly. It's already there. I was being silly. It's already there. We already have toString in event. I just wasn't looking at the interface above. Okay, so that's easy enough. So let toString a b equals f dot toString a caret. You like how I said caret but typed ampersand? Yeah. F dot toString b. All right. And let of int n equals okay. So what does of int mean again? This is basically turning an int into a rational. And whether it's float rational or not, this is going to be there, but we have of int there. Right. So the only thing that's funny about this, of course, is in the int case, we aren't actually doing anything, but we would do that. Because even for our int field, we have an of int, which is basically just identity. Okay, very cool. All right, so now we created our rational functor, and the whole reason for doing that, first of all, let's make sure that it actually returns a field like we think it does, and it doesn't. What's the problem? Okay. I wonder, let's go up to field and make sure field does have an of int, and I'm not crazy. It does. We're good. We're good on that one. I wonder if this is an abstract type thing that's screwing me. It could be. Let's put float ring into our REPL. Oh gosh, I realized how late it was. I need to go pretty soon. Okay, all those things work. We got float ring, we have float field. We're about to get the error in utop because I usually find it easier to parse that way. Okay, values do not match. Val of int to f.t start int is not included in val of int to t. Oh, because it's abstract. Nope, I messed up. I put a 1, but what if this was a float rational? Then a 1 wouldn't be correct, right? So what we actually have to replace this with is f.1. Yep, that was it. One little mistake. I used an integer instead of the 1 from our fields. Cool. So now we know that that satisfies our field type. And now we can actually just declare these using that functor instead. So let's go here. And we should be able to just say it as rational int field. Looks good. And rational float field. Cool. Nice. So we defined our rational functor. We have all that working. And then we were able to use that functor, apply that functor to our int field and our float field in order to create an int rational and float rational. And then maybe this is easier to maintain. I would actually argue that it's not any easier to maintain. partly because of how ugly this syntax is right here. Like, that's pretty painful to use. Maybe there's a way around it that I just don't know because I'm kind of a noob in OCaml, but it's a little bit ugly. But it's still a cool exercise to demonstrate functors. So that part is very cool. So yeah, I actually need to go. That was a great place to stop. Bye.